In this presentation, we're going to look at a specific type of probability problem that involves the use of a tree diagram. So we'll begin with an example. Box 1 contains 3 red balls, 2 blue balls, and 1 white ball. Box 2 contains 1 red ball, 3 blue balls, and 6 white balls. A die is rolled. If an even number is rolled, a ball is chosen out of box 1. If an odd number is rolled, a ball is chosen out of box 2. Find the probability of selecting a blue ball. What we're going to do is attempt to organize the information using a tree diagram. As you read through the problem, you need to determine what the first action is. When I read the first sentence of the problem, it simply says that box 1 contains 3 red balls, 2 blue balls, and 1 white ball. That's a descriptive sentence, but this does not imply any action. Sentence number 2 is the same way. Box 2 contains 1 red ball, 3 blue balls, and 6 white balls. Again, that sentence describes box 2, but it doesn't imply any action. The third sentence says a die is rolled. So that's where we'll begin our tree diagram. So I'm going to make a starting point on my tree diagram, and I'm going to make a column for rolling the die. Now, I want to consider whether I am really concerned about whether or not that die lands on a 1 or a 2 or a 3 or a 4 and so forth. In other words, do I really want to branch off from this into each of these possibilities, or do we not need that much detail? And I'm going to argue here that we don't really care exactly what number is shown on the die, but we're concerned as to whether the die rolls even or odd. And so I'm going to simply break off and say, okay, one option is that it rolls an even number, and another option is that we roll an odd number. Now, as we do this tree diagram, we're going to put probabilities on the branches. So I want to now consider what is the probability that I roll an even number. So we know that the probability of rolling even is 3 options, because we can roll a 2, a 4, or a 6 out of 6 total. So I'm going to do a probability of 3 over 6. And likewise, the probability of rolling an odd number is also going to be 3 over 6. The next thing we're going to look at is what happens in each case. So if we roll an even number on the die, the next thing that we do is we choose a ball out of box 1. So I'm going to go ahead and write a next column, and we're going to say that we're going to choose a ball. And we know it's coming out of box 1, and so I can either select out of box 1 a red ball, I can select a blue ball, or I can select a white ball. Similarly, if we roll an odd number, we're told that we choose a ball out of box 2. And furthermore, we're told that box 2 contains red balls, blue balls, and white balls. So again, we're going to come in, and on each of these branches, we're going to write a probability. So we want to look first at box 1 at the top part, and we want to ask ourselves, what is the probability that we choose a red ball? So we know that box 1 contains a total of 6 balls, and 3 of those are red. So our probability is going to be 3 out of 6 for the red. We know that we have 2 blue balls, so 2 out of 6 for the blue. And we know that we have 1 white ball, so 1 out of 6 for the white. Now we move to box 2. So we know that box 2 contains a total of 10 balls. We have 1 red, so our probability will be 1 out of 10. We have 3 blues, so 3 out of 10 for the blue. And 6 white, so 6 out of 10 for the white. Okay, so once our tree diagram is completed, now we want to actually find the probability of selecting a blue ball. So we want to answer the question. And so what I'm going to do is I am going to look at my tree diagram and I'm going to mark the paths from start to finish that result in a blue ball being chosen. So I could go from the starting point, I could go this way, go through the even, and select the blue ball. And as I do that, I'm going to write the numbers down on the path. So that would be 3 over 6. And then that would be 2 over 6. And we'll decide in just a second what we want to do with those numbers. Another option is this path, coming this way through the odd number and selecting the blue ball. And so again, I'm going to take my numbers, 3 over 6 and 3 over 10. Now, as you recall, we have keywords that help us determine when to add and when to multiply. So I want to ask a question. In order to end up with a blue ball, do you have to go the top path and the bottom path? Or is it the top path or the bottom path? You only actually have to do one of those in order to select a blue ball. So it can be the top path, which is represented by the first 2 numbers, or, and remember or indicates addition, the bottom path. Now, as far as the numbers along the path, if you're going to follow the entire path, you have to do both. You have to have rolled an even number and selected a blue ball. And remember that and means to multiply. Similarly here, we have to do an odd number on the die and a blue ball. So the easiest thing to remember is that you want to multiply along the paths and add in between your options. Okay, so let's go ahead and finish this up. 3 times 2 is 6. 6 over 6, or 6 times 6 is 36. 3 times 3 is 9. 6 times 10 is 60. At that point, I would go to my calculator and I would type it in and then let the calculator reduce that fraction. And so we end up with 19 over 60 for our final answer. Okay, so let's move on to a second tree diagram example. In a certain geographic location, 25% of the wage owners have a college degree and 75% do not. Of those who have a college degree, 5% earn more than $100,000 a year. Of those who do not have a college degree, 2% earn more than $100,000 a year. If a wage earner is selected at random, find the probability that he or she earns more than $100,000 a year. So we're going to begin by attempting to organize the information. We're first told that 25% of the wage earners have a college degree and 75% do not. So I'm going to place a starting point and I'm going to separate into those that have a college degree and those who do not have a college degree. And we know the probability for both of these. We know that 25% have a college degree, so my probability here is 0.25. And we know that 75% do not, so 0.75 is my probability that I choose someone who does not have a college degree. Okay, continuing with our second sentence, it says, of those who have a college degree. So these people, we know that 5%, so that's going to be 0.05, earn more than $100,000 a year. Now, that does mean that 95% don't, but I'm not sure that we really need that information, so we can add that if we want, but for now I'm just going to get down what the problem tells me. The third sentence says, of those who do not have a college degree, so this group, 2%, so that's 0.02, earn more than $100,000. If a wage earner is selected at random, find the probability that he or she earns more than $100,000 a year. So again, there are two ways that this can happen. We can go this path, and that would result in having chosen someone who earns more than $100,000. So that is going to be that 0.25 times the 0.05. Or, and remember that or means addition, we can go this path, which is going to be the 0.75 times the 0.02. Again, remember that you want to multiply along the paths and you want to add in between the options. And so when I put this in my calculator, I get 0.0275 as my final answer.